An LFO, or low-frequency oscillator, is another very common type of modulator found on a synth, used to produce continuous or cyclic modulation. That is to say, synth parameters that shift up and down in a repeated fashion, over and over, instead of just happening once, like with most envelopes. Comparing to an envelope for a moment then, whilst the envelope just goes up and down once here when you play a note, you can see the low-frequency oscillator just keeps on cycling up and down. As well as going up and down repeatedly, the other thing you might notice here is that it's going in two directions equally, so into positive modulation above the x-axis and negative modulation below, which is the other unique thing about an LFO modulation. This makes it ideally suited to things like tuning or panning modulation, where you can get a nice even spread across the stereo field as it shifts from left to right. One of the most common parameters to modulate with an LFO is a filter cutoff, and it's the technique used to create all sorts of classic sounds, like the wub-wub bass, which I'll show you shortly. So, taking this sound in Spire now, I'll just use a low-pass filter here to roll off the high frequencies, leaving just the low bass ones. And you can see them on the analyzer there. And now, going down to the LFO, which is one of the modulators on offer here, as there are two envelopes and two LFOs, and this is a pretty common setup. Then I just need to map the LFO to the filter cutoff, which is done in various ways on synths, like drag and drop, as we've seen, or in a matrix, as we'll see shortly, or sometimes in the modulators section, like here, where we have two target options. So I just select filter and cutoff 1, and then turn the amount up to max, and then we get the cutoff going up and down. Before going into specific LFO parameters, like waveform and frequency, let's look at the sim or symmetry control here. As you saw when we looked at the LFO on the graph a moment ago, it's capable of carrying out what's called bidirectional, or perhaps here symmetrical modulation. And you can see on the LFO display there's a line running through the centre, which represents no modulation, so the actual position of the cutoff dial. So the LFO, which is a sine wave, is shifting the dial up and down from its current position. If, however, we bring the symmetry up, sometimes this is just called offset rather than symmetry, then we move the modulation up to an entirely positive domain. So the LFO will just shift the cutoff dial up and down above its current position, without going below. So we get a brighter sound, and the bass frequencies are pretty much left alone. Or we could shift it the other way, so the cutoff only goes up to the current position, leaving the upper frequencies completely filtered out, and just bringing the lowest frequencies in and out. With the symmetry dial set to the highest position again, so the upper frequencies are being brought in and out. The other thing you can hear is that when I play repeated notes quickly like this, they're all sounding different again. The reason for this is that the LFO is running freely, so we're catching it at a different position or phase of its cycle when we play a note. You'll hear this even better if I slow the LFO down. So just like when we were trying to get a punchy and consistent sound with the oscillators before, the way we fix this here is by re-triggering or phase locking the LFO once again. In this case by bringing up the phase dial. So with just a small amount now, you can hear the LFO is re-triggering on every note. And changing the phase to a different position will totally change the transient sound. So with the phase at the top of the sine wave's first peak, we get a bright transient as the filter is wide open, letting the high frequencies pass through. And the LFO is then closing the filter with the downward slope of the sine wave to create the same effect as the pluck sound when we looked at filter envelopes. Or, changing the phase to the very bottom, we'll get the opposite, so the filter opening, like the mwap bass or wah-wah pedal effect. This is similarly demonstrated by changing the LFO waveform. So if I make it a downward sawtooth instead of a sine wave now, you can hear when I hold notes, we get the pluck sound repeating over and over. Whereas if I use an upward sawtooth instead, we'll get the filter opening over and over to make just the wah sound. As you've already seen, we can change the speed of the LFO. And as well as manual adjust, you can synchronize the speed to the tempo of your project. So then, we can step up in divisions of the bar. If I play a beat for a moment, you can hear that more clearly. And for an even better demonstration, let me set the phase of the LFO so it's at the very top of this sawtooth. And then with the LFO set to quarter notes, where there are 4 every bar, you can hear the downward filter sweep playing on every beat. Or, setting it to 8th notes, we can make it repeat twice each beat. Or with 16th note, 4 times each beat, so with a semiquaver pattern. So you can hear how the speed, waveform and phase setting of the LFO all play a big part in the type of sound the filter modulation creates with the bass.